let's do this again. The index finger's that way. Magnetic field is still down, isn't it? Yeah. Yes? The force should be which way? Should be toward you. It should repel it. Should kick it out of there. Right?
Get out of here.
Indeed it does. Okay, let's keep the current, let's put the current back the way the arrows go. Now let's switch this guy. Da, 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 da. Now the magnetic field is which way? It's up. Poopwich. All right. Now the magnetic field is which way? Okay, this is fun. Okay. So everybody point your finger that way. Put that middle finger up. Okay. We're doing this on YouTube. Which way should the force be? Should be toward you, right? This is all fun. The other way we used to do this was you put your arm in the direction of the thing. I'll show you the other way, right? Put your arm in the direction of the thing, right? And then you bend your arm so that you can bend your wrist in the direction of the magnetic field, right? Most people can't bend it backwards. Some people can, right? Which way is the force? It's out, isn't it? Isn't it? Yeah. Yeah. So it's like, there it is. That also works. So arm, you can do arm,
so this is your arm,
wrist. I like this better. Whatever works for you. Now, the story behind that was that I used to always invariably do one of them, and we'd sit there and practice them, right? And at the end, we'd always have one where the current the current was always up at an angle, right? And everybody would be like this, right? With this very serious look on their face, right? And I'd always have the camera ready, and I'd just go click, right? And I never actually like put like little red armbands on the people, but I probably would like. All right, so let's practice this. Let's practice the direction. Okay, let's practice the direction now. If you feel a cramp coming on, if you like, just shake it out. Shake it out. We don't want to, any injuries, no physics injuries. Okay, so our first one here. I see workers' comp coming, right? Okay, fingers are down. Yes, index fingers are down because that's the current. Magnetic field is this way. Which way is the force? Out, out of the page, right? It's a dot. Yeah? Now a smart person would get down. All right, next one. All right. All right, index finger is down. Magnetic field is which way? That way. Here's our magnetic field. Here is your current. Force is into the page. Yes? Uh-oh. Well, its magnetic field is down. I'm sorry, current is down. Magnetic field is, well, you can take any range of angles in this hemisphere or whatever, right? Any range of angles. Don't be doing this though. Never stick your middle finger behind, right? And it's still the force is out of the page, yes? Yeah. Right? It's just not as big a force. It's not the maximum force. That angle is some angle. What? Yeah. All right, next one. There we go. Index fingers that way. Magnetic field down. Index fingers. Current is this way. Magnetic field is down. Force is into the page, yes? What's this one? It's like, it's undefined, and it's also zero, because the angle between I and B is 0. Sine of 0 is 0, so it doesn't matter which way it is. It's nothing. All right. Well, B is the dots, so what does that mean? Out of the page. It's a bunch of vectors out of the page, right? So index fingers this way. It helps to breathe. Do a little breathing with this. Ready? Are you guys ready? Just kind of go. Right? It helps you just concentrate, right? Which way is our thumb? Down this page, correct? Yeah? Yeah? Index finger this way. Magnetic field's out of the page. Are we ready for the next one? Magnetic field is which way? Or I'm sorry, current is which way? Down. Magnetic field is which way? Which way is that? It's my right. No, I'm just kidding. That's left, isn't it? To the left on the page. Next one. Uh-oh, X's, what do those mean? Current is this way. Magnetic field is which way? Into the page, yes. Magnetic field is into the page. Your thumb is down. Okay? Uh-oh. Is this still at right angles to the magnetic field? Yeah, it is, right? So the current is... you can't even do it. That way, right? Isn't it? Magnetic field is this way. Isn't it down and to the left? Yeah? I should get my camera out. People are like, eh? Not everybody's like that, though. Okay, so now let's do ones where we're not just finding the force. Maybe we're trying to figure out the magnetic field. So now we've got to get off the stool because these become very active, right? Okay, let's see. Magnetic field is this guy, right?
Yeah.
Okay, so I know my index finger's got to be that way. My force has got to be up. Index finger's got to be that way, right? So therefore the magnetic field, the only way to do that without breaking my finger is that it's into the page. Yeah, did we get it right? Yes, we did. Yeah? So let's try another butter. Which way is the current? Well, let's see. Our thumbs have to point this way. Thumb has to point this way, doesn't it? The direction of the force. Magnetic field's got to be down. Thumb is this way. Magnetic field is down. Have we got it? Ha! Yeah? Yeah, yeah? Are we good? How good are we? All right. Dun, 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 dun. Now I don't tell you the direction of the magnetic field, but you know it's north to south, don't you?
Into the page.
So magnetic field's that way. Current is this way. Thumb is into this page, yes? As it sits here. Okay. Current is this way. Magnetic field, which way is it? It's down because it's north to south. Force is out of the page. I think we did this one, right? With the... Did I turn this off or is it like just heating up? Okay, good. Okay, now dun 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 dun. Now we could combine, and I think I do this on the test. The first page of the test has this circuit on there, right? And you have to calculate the current. And every now and then somebody forgets Ohm's law, which is sort of sad, right? But if we knew the voltage and the resistance, we'd say voltage divided by resistance and get the current, right? And then the current goes from positive to negative. Now, let me let you in on a little dirty secret. Do positive charges really move?
No.
No, it's really negative charges that move. So in this circuit, it's really electrons are going clockwise. But we don't do that in physics. We had a 50-50 chance to get it right. We guessed wrong, and we haven't changed. So we say positive charge moves. The direction of current is the motion of positive charge. And positive charge is from positive to negative. So in this place here, it's going down, isn't it? It's going anti-clockwise. It's going from the big side of the battery to that side, right? So our index finger should be down. Which way should our middle finger be? From north to south. And your thumb is out of the page. Is it cheating to show up to like the skill set with like BIF written on your fingers?
And R and L.
I don't know. Yeah. Okay, so now let's do some that the book likes to do this, right? So we'll do some of these, right? Okay. So look at this. Now I call these map problems. We're on a map somewhere. Picture yourself on a map. Okay, I've got the compass rose there, so north is really just up the page, south is down the page, west will be to the left, east will be to the right. If it's a map, into the page is vertically downward, yes? And out of the page is vertically upward, yes? We're in that world. Okay, we're mapping this, we're making this a map. Really you need to tip it flat to see it, right? So if it's lying on a piece of paper, it's much easier to do maybe, right? So again, north, south, east, west are the direction that we say. Out of the page, I'm going to interpret as vertically upward. Into the page is vertically downward. Okay? So if the current is up, well, up is out of the page, right? current is out of the page, vertically